Hello viewers, in today's class we are going to discuss one important problem from Dirac Delta function, right? So in our earlier videos we have discussed a lot of problems related to Dirac Delta function. So in this session we are going to find out the Laplace transform of Dirac Delta function, in which we have a quadratic function, right? So we have to find the Laplace transform of delta of 2t square minus t minus 3, right? So let us see how we can find out the Laplace transform of delta of this quadratic function using the properties of Laplace transforms and Dirac delta function. So now let us first define the Laplace transform of a function f of t, right? So the definition of Laplace transform of a function f of t is given by this integral, that is 0 to infinity f of t e raised to minus s times t, and here we have dt, right, where s is a parameter which may be a real number or complex number, right? Now let us take f of t as delta of 2t square minus t minus 3, so that we have the Laplace transform of delta of 2t square minus t minus 3 as the integral 0 to infinity, then f of t is delta of 2t square minus t minus 3, and here we have e raised to minus s times t, and here we have dt, right? So now our aim is to evaluate this integral, right? So to evaluate this integral, what we have to do, we have to make use of one important property of Dirac delta function. So here we'll make use of one important property of Dirac delta function, which says that the Dirac delta of g of some function, say uh, t, that is delta of gt, is equal to the summation I is equal to 1 to n, and then we have delta of t minus ti, and here we have the mod of the derivative of g of t at the points ti, right? So this is an important property of Dirac delta function which can be used to evaluate this integral. So here what we will do, we'll take this function, which is a quadratic function, as g of t, right? So we'll assume the function g of t as 2t square minus t minus 3, right? So that now this integral, it reads as 0 to infinity, then we have delta of g of t, and here we have e raised to minus s times t, and this is dt, right? So now we have to find the value of this term, that is delta of g of t, which is present here, delta of g of t, and the value of delta of g of t is given by this expression, right? Now we'll see how we can find out the value of this expression, right? So what we will do, we have g of t as 2t square minus t minus 3. So let us find out the roots of g of t is equal to 0, right? So whenever we have to apply this property, we have to first find out the roots of this equation. G of t is equal to 0. So we have 2t square minus t minus 3 is equal to 0. So now we can easily factorize this quadratic polynomial by making use of the method of splitting the middle term. So now we can write it as 2t square, then we have minus 3t plus 2t, splitting this middle term, then we have minus 3 is equal to 0. So here we can take t common, so we have 2t minus 3, and then we have here 1, 2t minus 3 is equal to 0. So 2t minus 3 and t plus 1 is equal to 0. So 2t minus 3 is equal to 0 gives us t is equal to 3 by 2, and t plus 1 is equal to 0 gives us t is equal to minus 1, right? So this equation g of t is equal to 0 has two roots, right? So we have two roots of this equation g of t is equal to 0. So let us name these two roots as t1 is equal to minus 1. This root may be taken as t1 and this root may be taken as t2, right? So we have t2 is equal to 3 by 2, right? Now let us differentiate g of t, because here we want to have the derivative of g of t, right? So the derivative of g of t is g prime of t. So g prime of t is the derivative of 2t square minus t minus 3. So we have 4t minus 1, right? So the derivative of t square is 2t and this is 4t. 2 times 2t is 4t and the derivative of t is 1 and the derivative of 3 is 0, being a constant, right? So the derivative of g of t, that is g prime of t, is equal to 4t minus 1. So now let us find out the absolute value of g prime of t1 and the absolute value of g prime of t2, right? So the absolute value of g prime of t1 is g prime of t1. T1 is minus 1. So we have here mod of g prime of minus 1 is obtained by substituting here t is equal to minus 1. So we have 4 times minus 1 minus 1. So here we have mod of minus 4 minus 1, that is equal to mod of minus 5, that is equal to 5, right? And now we have to find the mod of g prime of t2. So this value is mod of g prime of t2. T2 is 3 by 2. So we have now mod of here will take t is equal to 3 by 2. So here we have 3 by 2 minus 1. So this is 2 2s are 4. This is 2 3s are 6. So we have 6 minus 1. That is mod of 5. That is equal to 5, right? So we have obtained the value of g prime of t1, mod of g prime of t1 and mod of g prime of t2. So now let us apply this property. So delta of g of t is now equal to sigma. This is the summation sign and I runs from 1 to n, right? So here we have only two roots. So it implies that I should have the values 1 and 2, right? Because the number of roots of the equation g of t is equal to 0 are 2, because it is a quadratic equation. So we have only two values of I, right? So we can write I is equal to 1 to 2. Then we have delta of t minus ti, and here we have mod of g prime of ti, right? So now removing this summation sign by taking the values of I as 1 and 2, right? So when we take I is equal to 1, then we have delta of t minus t1 mod of g prime of t1, and then we have I is equal to 2. So delta of t minus t2, and then we have mod of g prime of t2, right? Okay, now let us substitute the value of t1 and t2. So we have delta of t minus 1. Here we have t1 is equal to minus 1. So this becomes plus 1. and here mod of g prime of minus 1, right? And here we have delta of t minus t2. T2 is 3 by 2, and here we have mod of g prime of 3 by 2, right? Okay, now we can write delta of t plus 1, and here we have the mod of g prime of minus 1 is 5. So here we have 5, and here we have delta of t minus, this is 3 by 2, and then we have here mod of g prime of 3 by 2, which is also equal to 5, right? So delta of g of t is now equal to this expression, and let us substitute delta of g of t in this expression. So now the Laplace transform of delta of 2t square minus t minus 3 is now equal to integral 0 to infinity, and delta of g of t is now equal to this expression. So we have delta of t plus 1 divided by 5 plus delta of t minus 3 by 2 over 5, and here we have e raised to minus s times t, and here we have dt, right? So let us take 1 over 5 common. So we have 1 over 5, and then we have the integral 0 to infinity delta of t plus 1 times e raised to minus s times t dt, and then we have the second integral 0 to infinity delta of t minus 3 by 2, and then we have e raised to minus s times t, and here we have dt, right? So what we have done here, we have multiplied these two terms by e raised to minus s times t and taking 1 over 5 outside the integral, and now we have the sum of two integrals involving the Dirac delta function. So now to evaluate these two integrals, we can make use of the definition of Dirac delta function, which says that if we have the integral, say from minus infinity to infinity, and here we have a function, say f of x, delta of x minus a dx, then the value of this integral is equal to the value of this function at x is equal to a, right? So we have here f of a, right? So the first integral is 0 to infinity. We have here delta, we can write e raised to minus s times t as f of x or f of t, and here we have delta of t plus 1, and here we have dt, right? So the value of this integral is equal to the value of this function at t is equal to minus 1, because see, t plus 1 can be written as t minus minus 1, right? So the value of this integral is e raised to minus st, and here we have t is equal to minus 1. So here we have e raised to minus s times minus 1. So taking t is equal to minus 1, so we have minus minus plus, so we have simply e raised to s. So the value of this integral is e raised to s. Let us calculate the value of this integral. So now we have this integral 0 to infinity e raised to minus s times t. Then we have delta of t minus 3 by 2 and dt, right? So the value of this integral is the value of this function, that is f of t. Here we have f of x, and at t is equal to 3 by 2, right? So e raised to minus st, and here we have t is equal to 3 by 2, right? So we have e raised to minus s, taking t is equal to 3 by 2. Here we have e raised to minus 3s over 2, right? Okay, so the value of this integral is e raised to minus 3s over 2. So viewers, now the Laplace transform of delta of 2t square minus t minus 3 is now equal to 1 over 5. Here we have the factor 1 over 5, and then we have e raised to s plus e raised to minus 3s over 2, right? So we can now conclude that the Laplace transform of delta of 2t square minus t minus 3 is equal to e raised to s plus e raised to minus 3s over 2 divided by 5, right? So this is how, by making use of the concept of Dirac delta function and the various properties of Dirac delta function, we can find out the Laplace transform of the Dirac delta function containing a quadratic polynomial. Hello viewers, in today's session we are going to discuss an important problem related to Dirac delta function, right? So in this class we are going to find out the Laplace transform of functions involving the famous Dirac delta function. So here we have to find the Laplace transform of this function, that is minus t cube and delta of minus 2t plus 1, right? So viewers, we have already solved a lot of problems in our earlier videos related to Dirac delta function, and in this session we'll solve this problem. So let us start. So let us first define the Laplace transform of a function f of t, right? So the definition of Laplace transform of a function f of t is given by this integral 0 to infinity e raised to minus st, where s is the parameter which may be a real one or complex one, right? And here we have f of t, right? So this is the definition of Laplace transform of a function f of t, right? Now let us replace f of t by this function, right? So we'll take f of t as minus t cube and delta of minus 2t plus 1, right? So we have now Laplace transform of minus t cube delta of minus 2t plus 1 is equal to 0 to infinity e raised to minus s times t, and f of t is minus t cube delta of minus 2t plus 1, right? So here we have dt. So now we have to calculate or to compute this integral. So now let us rearrange the terms. So we can take this negative sign outside the integral. We have 0 to infinity. Then we have t cube, and then we have e raised to minus st, and here we have delta of minus 2t plus 1 dt, right? Okay, now to move further, what we will do, will make use of one important property of Dirac delta function, right? Now see, the property goes like this: if we have delta of, say, ax minus b, then we can write, if we take a common, then we have x minus b over a, right? So delta of ax minus b is equal to delta of a times x minus b over a, right? So if we take this a outside, then what we do, we write 1 over the mod of a, right? And we write delta of x minus b over a. So delta of ax minus b is equal to 1 over absolute value of a, and a is the coefficient of x, right? And x minus b over a. So we'll apply this property in this term, that is delta of minus 2t plus 1. So now this term, that is the delta of minus 2t plus 1, can be written as the delta of minus 2, and we have here t, because we are taking minus 2 common, so we have here t minus 1 over 2, right? So here the value of and this a is a minus 2, right? So now applying this property, we can now write 1 over mod of minus 2, and we have delta of t minus half. So mod of minus 2 is positive 2, so we have 1 over 2, delta of t minus 1 over 2, right? So now this expression can be written as a negative. Then we have 0 to infinity. We have t cube e raised to minus s times t, and this term can be replaced by this one. So we have half and delta of t minus half, and here we have dt, right? Now we can take half outside the integral. We have minus 1 over 2, 0 to infinity. Then we have t cube e raised to minus st, and delta of t minus 1 over 2 dt, right? Okay, now see here with the delta of t minus half, we have this function, right? So let us call this function as g of t, right? So we can now write minus half, 0 to infinity, and then we have g of t, because t cube times e raised to minus st can be taken as some function g of t, and here we have delta of t minus half, and here we have dt, right? So now we have a very simple integral here, because we can make use of the definition of Dirac delta function. The definition goes like this: if we have the integral minus infinity to positive infinity, and here we have some function, say f of x delta of x minus a dx, then the value of this integral is equal to the value of this function at this point, that is x is equal to a. So this is f of a, right? Because we know that here we have minus infinity, here we have plus infinity, and here we have x minus a, and this point say it lies here, x is equal to a. So the delta function has the value at only this point, that is x is equal to a, right? And apart from x is equal to a, the delta function is 0 in the entire number line, that is minus infinity to a, and then a to infinity, right? So the value of the delta function, it exists only at this point, x is equal to a, right? Or in other words, we can say that this spike exists at only this point, x is equal to a. But here we have the limits, that is from 0 to infinity, right? Here we have 0, here we have infinity, and here we have delta of t minus half, right? So t minus half implies that we have the point t is equal to say half, right? So the delta function, it exists at only this point, that is t is equal to half. So our point a is the half here, right? So the value of this integral is now equal to minus half, and the value of the function g of t at this point, that is half, right? So we have g of half, right? So now we have to simply calculate the value of g of half. Now see, g of t is the function t cube e raised to minus s times t. So g of half is now equal to 1 over 2 raised to 3 and e raised to minus s times half, right? So now we have minus half, and g of half is now 1 over 2 cube is 1 over 8, and here we have e raised to minus s over 2, right? So this is 2 times 8 is 16. So we have minus 1 over 16 e raised to minus s over 2, right? So viewers, the Laplace transform of this function is equal to minus 1 over 16 times e raised to minus s over 2, which can also be written as minus 1 over 16 and e raised to s over 2.